Okay. Thank you, Mark, for the introduction. My name is Khalad Hasan, and I am from the University of Manitoba. Today, I'm going to present the paper titled AirPanes, Two-Handed Around-Device Interactions for Pen Switching on Smartphones. Co-authors of this paper are Dr. David Ahlström from Alpen Ardria University and Junhyeok Kim and Dr. Pourang Irani from the University of Manitoba. Mobile devices are ubiquitous today. We frequently use mobile phone as it allows us to access information anywhere, anytime. Estimated suggest that in 2016, mobile phone generated 27.8 billion more queries than desktop computers. And on those devices, we frequently perform different decision-making tasks. One example of such decision-making tasks include booking a hotel for an upcoming trip. On desktop computer, we have access to large display space. We have learned a lot how to organize and how to lay out different information and how to use this to help decision-making. However, on mobile devices, the display and interaction space is limited by its physical boundary. It affects input to the mobile devices as well as limit interaction capabilities to access information to make different decisions. For example, in this video, you can see that a person interested in purchasing a camera frequently switch between list view and detail view, and also flick through a long list of items, which results in less efficient information exploration. The surrounding void space of mobile device is considerably larger than the small screen space. Ideally, mobile device could be augmented with a virtual interactive plane that could extend beyond its physical boundary for storing and retrieving on-device content. Instead of interacting with a small touchscreen, a user can use the large surrounding space for exploring information. So based on this idea, in our paper, we proposed AirPane, a novel strategy to structure mobile interfaces using the in-air space for accommodating multiple pens or multiple windows that are commonly seen on mobile applications. More specifically, we explored how to design that space for accommodating different windows that we commonly frequently use on mobile applications. And also, we were interested in a task where user requires to interact with a large information, that means a large amount of data, before making a final decision. Now, I'd like to briefly mention some of the work that are related to my project. Previous research have demonstrated that around-device interaction is possible, and they propose different interaction capabilities with a wide range of sensing capacities. For instance, they used IR sensor, magnetic input, and commercial solutions, like commercial tracking solutions like Vicon tracking system. Motivated by their work, we explore how to use the around-device space for storing and browsing information. Now, I'd like to show you one of our previous projects, which is called AD binning, where actually we explored the idea of using 2D plane parallel to the device for browsing on-device content. So for instance, here, all the camera search information are offloaded around the device, and a user can just simply move his hand in different location on that around device space to get information on the corresponding item. Also, later in a study, we found that people are comfortable performing in-air gesture in a 3D space above and below the device. So these results basically motivate us to consider using the 3D space for interacting with content, on-device content. And we are specifically interested in how to design that space to accommodate multiple windows. Well, we have started this project. We found that there is one more space, which we call thumb reachable space, like this space here. We realized that user can also use that space just above the device that is reachable via the thumb. So here in this video, you can see that a participant is moving his thumb to access the thumb reachable space. And here you can see the corresponding thumb reachable space emulated in a cave environment. And also, you can see the actual size of the thumb of that space. So next we conducted a series of study to actually answer how to design the media space, or how to use the media space for designing applications that require users to interact with multiple pens. In the first study, we explore where to arrange items within this accessible space, and different methods to select items that are located in that space. After pilot testing with different number of items that can be placed in that space, we decided to place 12 wedge-shaped items in 2 or 3 layer item management style. And also we tested 3 different selection techniques, dual, where actually user requires to keep their hand static for a certain amount of time. The next technique we investigated tilt, where a user needs to quickly tilt the device sideways while keeping the thumb position within the item region. And also we considered touch that involves moving the thumb to the desired in-air region first and then quickly tap on the screen. So here in this video, you can see the tilt selection technique with 2-layer item management style. Now our results reveal that items that are positioned at the far end tends to be troublesome to select than the items that are located in the middle. We believe that one possible reason could be like outer items that are located farther away require stretching the thumb, and that actually take longer time to select items that are located in the middle position. We did not find any significant difference for the selection technique that we tested in our study. Now, at this point, we actually designed, or we actually explore how to design the thumb reachable space. So we next explore how to design the space that is reachable via the other hand. So we investigated a number of different AirPane layout or item management style, and also we investigated the target size, minimum target size that should be placed in that, like within that style. So for instance, we investigated stack layout where 4 panes are placed, one top of another, 2 planes above the phone and 2 planes below the phone. And here is a corresponding video of that stack layout. We investigated tile layout where 4 panes are placed side by side. This requires less in-air hand movement for pen switching, but more precise hand movement when interacting with pen content. And here is the corresponding video for the tile layout. We included tilt stack layout where 4 pens are grouped into 2 pairs. So only 1 pair is accessible at a time. So when the device is tilted with an angle less than 45 degrees, then first 2 pens can be accessed. To access the remaining pen, the device needs to be tilted with an angle greater than 45 degrees. And here is the corresponding video showing the tilt stack layout. We next explore tilt tile layout where pens are grouped in pairs side by side, and tilt is used to switch between the pairs. And here is the video for that pen. We also divided the thumb reachable space into 4, like approximately 4 equal-sized shape or equal-sized region. And here a user can just simply move his thumb in different location to access the corresponding pane. So we tested this 5 layout with a target selection task where targets were placed randomly in different panes. Our results suggested that stack layout is faster since there is no second activities needed to switch another pane, such as tilting the device to access the second pair and so on. So based on this information, we actually next moved to our final study where we design AirPanes and compare its performance with the standard touch interface. So at this point, we know that we have 2 spaces. One is thumb reachable space, and another is the large in-ear space that can be reached with the dominant hand. So our next question is, what kind of application is suitable for this application? And we would like to show that, yes, this space can be used for accessing large amount of information. We found that m-commerce application would be a suitable for demonstrating the city of AirPanes. So that's why we decided to use an AirPane as an example application to demonstrate the capabilities of AirPane. And also in such application, a user need to access through the long list of items to make a decision. So we also want to see whether such in-ear space could be used for decision-making tasks. So to see what are the features should be supported, to get an insight on this, we first actually explored 15 e-commerce applications that listed in this slide. And from this particular survey, survey on 15 e-commerce application, we found that small display size on mobile phone frequently forces designer to switch or to structure the interfaces into multiple panes. For instance, we found that for e-commerce application, filter is a very common option for all the e-commerce application that we investigated. And when a user tap on a certain item or an option, then actually it opens up a new window with the corresponding information. So when users select the corresponding price here and click on the OK button, then actually it opens up a new window with detailed results and so on. And when a user tap on the detailed window, it again opens a new window where actually the item can be seen with more details. And if the person is interested in purchasing that item or want to add it to his favorite, then he could just tap on that bookmark item and so on. Now, as we know that we need to support, for instance, filter option, detailed result option, and search result list options and so on, and favorite options. So our next question was how actually we can organize these multiple panes in AirSpace. So now I'm going to show you our approach that we took in our AirPane design. So we placed the filter option below the device. We placed search result above the device. And also we placed the favorite items in the thumb reachable space. This is just one of many alternate design that we could use for our AirPane design. For instance, we could just use a single stack layout. In this way, all the planes would be accessible with the index finger of the free hand. So now here is a video of corresponding our AirPane design. So here a user is moving his hand below the device to select filter option. And if he moves his hand above the device, then actually he could get the detailed result information. He could add an item with a, like in the favorite with a pinch gesture. And when he is done with all the accessing all the items, he could just move his hand to the resting position and move the thumb to access the thumb reachable space to access items that are added to favorite. We also compared the performance of AirPane with the standard touch technique. So here is the implementation of corresponding standard touch technique, where actually users frequently need to switch between multiple views. So our results reveal that AirPane is significantly faster than the traditional touch input while accessing information for a decision-making task. One of the main advantages of AirPane is that it reduces browsing time by taking the advantage of its in-air hover state. With AirPane, detailed item information can be inspected without having to switch between the list view and the detailed view. Now, I would like to briefly mention some of the challenges of this project or the AirPane design. So one challenge is generalization, whether we could actually apply the same strategy or AirPane design to any other applications and so on. Because we know that the AirPane is, AirPane performs really well when the interfaces are structured with multiple windows and contents are listed in a list view and detailed view styles. So to get that information or to answer the generalization issues, we actually investigated 2 applications under these 5 top list categories. So social networking, searching, browsing, SMS, phone, and email applications. And we've observed that due to the limited display space, frequent pan switching is common for all of our investigated application. For instance, here in this email application, you can see that email is first shown with a snippet, and then if you tap on a snippet, it actually opens up a detailed view. Since AirPane reduces the need of browsing through in-air hover state, and also we believe that most of the application would be benefited by using the AirPane design. And also, participants frequently mentioned the arm fatigue issue. They were mentioning that due to lack of tactile feedback or haptic feedback, they actually feel arm fatigue more. So like AirPane could also be used in a context where like user coordinate landmark, for instance, including body mark for organizing and retrieving AirPane content. So I'm actually at the end of my presentation, so I'd like to just quickly recap my presentation. So in this paper, we actually explore AirPanes, or we proposed AirPane, a novel strategy to structure mobile interfaces with in-air space around the device. Thank you very much for your patience hearing. Now I'd like to open the floor for questions.
Ja, hello. Is it on? Yeah. Raimund Dachselt, Technische Universität Dresden, Dresden University of Technology. Thanks a lot. A very interesting talk and interesting work. I noticed in your approaches, you studied many approaches where basically the mobile phone was held in a static position, and you used the space above or beside for interaction with your hands. Did you also think about doing that vice versa? That means moving the phone through different zones. We did a study here in 2014 at SIGCHI that this is very beneficial to actually move your phone through space and make usage of a changed display according to the space where the phone just happens to be. So this is more explicit a little bit, and you don't have the problem of different zones where you might miss them because you hold it in your hand.
Yeah. Oh. Yeah, like it's a very interesting like question. So in our design, actually, we did not consider moving the phone. We always ask the participants to keep the phone static. We actually did not ask like using any peephole technique where people will move their phone and so on. So it seems to me one of the reason was we would like to add the freedom to use the other hand to like use the dominant hand for selection technique, because we were using pinch and other different lift off and other different gesture that actually requires precise selection and so on. So that's why we were interested in using the non-dominant hand to hold the device and using the dominant hand to give the precise selection and all other operations.
Hi, this is Andrea from KAIST. I have a question. Clicking on something and then going back, it's usually considered an anti-pattern in UX. It's called also the pogo stick. Like you actually jump in a menu and then you go back and jump. So many applications, including the Gmail that you have shown before, let you swipe to different content. So I was wondering if you consider a swipe as an alternative instead of thank you.
Thank you for this question. So yes, in our design, we did not consider swipe. For instance, I can assume that all the panes could be arranged in a carousel fashion where actually you will swipe. Like for instance, if you have 20 email, you will just swipe this one. So the advantage of AirPanes is you could actually directly access an item. So you don't need to actually go through any sequential process. That means swiping one item. So if I want to see like email like day before yesterday, then I may need to do 15 swipe. Whereas with AirPane, you could just directly go to a particular position like instead of swiping that one. So yes, we did not consider this one as swiping gesture would be pretty similar performance to the touch interface because it just gives you sequential access to information.
So I was wondering about the fatigue issues as to, so in stuff I've read in the past, people started drooping. Did you have an issue with that? And can you cope with that, or is that a problem, or did people keep their hands in your planes? So basically, when actually we were investigating the AirPanes, we actually asked the participants to hold the phone with their left hand, and it seems to me we don't have any issues with the left hand. Participants mainly complained about using the right hand for exploration because they need to move their finger below the device, finger then above the device, and also using the thumb space. So after a certain number of trials, they were complaining that it's kind of tiring compared to using the touch interface, because in touch interface, you always have the touch surface where you can rest your finger and do the panning and so on. So we did not actually investigate the fatigue issues in details, but we, right now, actually, we are planning to, also consider that one as a future direction to explore further. Yes. 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 Yes, yes. Okay. Thank you. Okay. Thank you.